Let's go ahead and solve the palindrome problem on LeetCode. This problem is classified as easy. Given an integer x, return true if x is a palindrome and false otherwise. A palindrome, or an integer, is a palindrome when it reads the same forwards and backwards. For example, 1 to 1 is a palindrome, while 1 to 3 is not, because 1 to 1 in reverse is still 1 to 1, whereas 1 to 3 in reverse becomes 3 to 1, and so it's not the same. So we're going to solve this in two different ways. The first way, which is more beginner oriented, and it's kind of what how you initially go about solving the problem, or how you think about solving the problem in the beginning, is we're going to convert x into a integer x into a string as such. So string, let's say s, is equal to integer dot to string x, and this is how you turn an integer into a string on Java with one line of code. And then what we're going to do is we're going to create two pointers, int I equals 0. This pointer starts at the beginning of the string, and int l, which is equal to s dot length minus 1. This pointer starts at the end of the string. Then what we're going to do, we're going to say while l is greater than I, if s dot char at I is not equal to s dot character at l, then return false. Otherwise, I plus plus, and then l minus minus, and then return true. So if we take the example of 1 to 1, I points at 1 and l points at the last character, which is also 1. And what we're saying is if s dot character at I, so s dot character at 0, which is 1, is not equal to s dot character at l, which is also 1, then return false. In this case, they're true. So what are we going to do? We're going to return I plus plus, or we're not going to return anything. We're going to increment I and decrement l. So now I plus plus is at 1 and l is also at 1, which is they're both at 2. So we go to the while loop, and is 2 greater than 2? No, stop, and return true. Let's submit and see if it works. Okay, perfect. Now let's move on to solution 2. Okay, so for solution 2, we're actually going to solve it without converting int x into a string. And if you notice in the description, we have a follow-up question which asks us, could you solve it without converting the integer to a string? And that's what we're going to do now. Okay, so the first thing we're going to do is we're going to check if x is a negative number. So if x is less than 0. If it is, we're going to return false immediately. If you notice in this example, minus 1 to 1 is false, because although the numbers are 1 to 1, we have a negative. And if you read it from right to left, it becomes 1 to 1 minus, so it's not a palindrome. Okay, following that, we're going to store x into another variable. We'll call this original, because I want to modify the value of x and store it into another variable, which is going to be reversed. So that's what we're going to do now. We're also going to create another variable called reverse, and it's going to be equal to 0 initially. Now what we're going to do is, if for example x is equal to 121, we're going to retrieve the last number of x, which is 1, store it in our int reverse. Then we're going to modify x by dividing it by 10, so we move on to the rest of the numbers. So after we do x divided by 10, we're going to be left with 12, and we're going to store 12 in reverse, and then we're going to divide by 10 again until we reach 1. Then we're going to store 1, and then we're going to compare our reverse to our original. So how we're going to do that is we're going to loop while x is greater than 0, because remember, we're going to divide by 10, and eventually we're going to run out of numbers. So while x is greater than 0, int digit, which is the last number which we're going to retrieve, is going to be equal to x modulo 10. And what modulo 10 will do is it will retrieve the remainder of the division of x by 10. So for example, 121 divided by 10, that's 12 with a remainder of 1. Now we're going to be building the reverse number, and the way we're going to do that is like this. So int reverse is equal to 0. Reverse is going to be equal to reverse times 10 plus the digit that we just retrieved. So for example, x is equal to 121. We retrieved the 1 in this line of code, and then reverse is going to be equal to reverse times 10, which initially is 0 times 10, which is 0, plus the digit, that's 1. And then we'll take a look at the rest after we finish the code. Then finally what we're going to do is x is equal to x divided by 10, so we can move on to the next number. And then finally what we're going to do is we're going to return original equal to reverse, which will return true if they're equal and false otherwise. Let's submit and see if it worked. Okay, perfect. So just to go back to this example, first of all, we're storing x into a variable called original. So original is going to be equal to, let's follow example 1, is equal to 121. Int reverse is initially equal to 0, while x is greater than 0, because remember, the only way we're going to look through every number of integer x is by dividing by 10, and eventually when we run out of numbers, we're going to get 0, so that's when we stop. Int digit is equal to x modulo 10, meaning we just retrieved the last number. Reverse is equal to reverse times 10, which initially is 0 times 10 plus digit, so reverse is now equal to 1. And then x is equal to x divided by 10, so now x is equal to 12, which is still greater than 0. So int digit is equal to x modulo 10, you're going to get 2. Reverse is equal to reverse times 10, which is 1 times 10, which is 10, plus digit, which is 2, so now that's 12. X is equal to x divided by 10, therefore we're left with the 1, which is still greater than 0. So one more time, we retrieve the 1. Reverse is equal to 12 times 10, which is 120, plus digit, which is 1. And then we divide x one more time by 10, and we see that it's equal to 0. So the while loop terminates. And then we're comparing original with reverse, which is 121, and reverse is 121. And since they're true, since they are equal, we're going to return true. So I hope you found that video helpful, and thanks for watching.